When you are doing C programming is a procedural language. Again, general purpose means the multi-purpose, like that hammer. You can do almost anything with C programming. All of modern systems, all of those modern system means all of those critical system, like operating system, kernel, and all of those critical software programs that are working with the hardware closely. All of those system software that directly sits on the top of your hardware, the hardware component, those are critical software programs, because they will be handling lot of hardware APIs. Means they will be working with the hardware too closely. So those are the languages which are very much powerful, and C is one of them. And mainly C is the even till date today, C is considered as the best system programming language. Means if you have an IoT board, if you have a microcontroller, microcontroller is the computer, that whole computer in a single IC, integrated circuit. So the IC will contain all of those von Neumann things, all of those architectural things, primary memory, CPU, whatnot, everything that a von Neumann architecture should have. So that will make a microcontroller, and we can program this microcontroller, because when we having a computer, we could also have a software program. So in case of microcontrollers also, we can program that microcontroller. Again, we are working with the hardware too closely. We are actually, when we are programming a microcontroller, it is same like we are installing operating system on a motherboard, on a hard disk, which is again connected to the motherboard. So in all of these cases, all of these are operating system. This firmware means the system that is being installed in the microcontroller. All of these things, these are system software, and C is the best system programming language. Means these critical systems can be developed and being developed even today using C programming language. Your operating system, be it Linux, Unix was totally developed using C programming language. As I was talking about the brief history of C language, I was talking about this also, that the Unix system was totally developed using C programming language. So till date, C programming language is the best system development language. Even your Windows 10 is the kernel, the Windows NT thing is developed using C programming language. If you ever try to do some native programming using native APIs of Windows 10, if you use Windows 10, then the Windows NT kernel, that will also provide you the native SDK. Native SDK is the software development tool. In this case, this will be a framework. In this case, the SDK will be the framework. This will not, as I was talking about SDK or SDT, will provide you lot of programs, compilers, interpreters, linkers. But in this case, SDK is referred to as a framework. Framework is nothing but collection of libraries. stdio.h, math.h, conio.h, these are all libraries. So Windows NT kernel is developed using the C programming language, as well as it provides us, Microsoft has developed a total framework that is called the native SDK, Windows native APIs. Native APIs are nothing but all those functions that are provided or written inside all of those header files, C header files, or dynamic link libraries with the extension of DLL. All those files, they will be having these function definitions. So when we are simply using the VB.NET, or we can also do this thing using C programming also. When we are writing a C program, and basically C programs and many other like core Java or Python, at first you will be using just command line. when I will be doing the practical sessions, you will be seeing that I'm just taking user input in console, I'm compiling in console, the black screen as a cursor appears and everything's they're just going on inside the compiler or inside the Windows shell or command prompt, and in case of Linux it will be the shell or terminal. So when I will be doing the actual C programming, I will be first for Windows I will be opening the command prompt or simply prompt, which provides us the access to the Windows shell. And in case of Linux we will be using the terminal. Both of them are command line utilities, or the terminal means the interface which let us access the shell, all those APIs that the shell provides us. API means all those handles that I used to draw a diagram like this. This is a layer of abstraction. There will be many handles or APIs, and finally they will be accessed by the upper level of abstraction. Hardware will provide you APIs, the systems software, the operating system, it will be using those APIs. Then again, operating system means the kernel part, the core part will be accessing the hardware APIs, and the APIs that your kernel provides will be further accessed by the shell, and the shell will again provide you a few APIs will be finally utilized by your application. In this case also, our Windows NT kernel is totally written in C programming language, and also Microsoft has developed a SDK or a set of libraries which is called a framework. That framework contains set of libraries, and libraries like libraries are the modules. As I have a video uploaded about what is the difference between module, application, program. If you watch that video, you can understand my words like when we are talking about a library, that is similar thing like a module. My module is also incomplete in nature, cannot be executed by the processor, just a piece of code. And similarly, the same thing is also the library and module, both are same thing. So framework is the collection of these libraries or modules which are all incomplete in nature and can be utilized further in any other source code. So Microsoft has developed a framework which contains all of these libraries or modules, and all of them, they are actually using the APIs of the kernel. So it is sitting on the top of the operating system. So if this is all about native programming, when you are, let's say we are trying to write a C program, I will also show you definitely. As for basic programs written in any language, C, Core, Java, Python, anything, C++, we will be doing things in terminal, in Windows prompt, for Linux in terminal. So that is not satisfying. That is not a commercial application. When building a commercial project, a program with graphical or an application with graphical interface, then it will be definitely a requirement to design a graphical user interface where we can make use of the mouse cursor, we can click on a button, we can type some text and things in more fashion way. So in this case, we have two things, two methods. Either we can implement, we can make use of that Microsoft built native SDK for native programming, or we can use some other GUI framework or graphical user interface framework like Qt. Python is always preferred to when making graphical user interfaces. Python, my Python developer friends, I have many Python developer friends, they make use of that Qt framework. So even C++ can also make use of that library, that framework, which is Qt framework. So Qt, just Qt, it's a graphical user interface framework or GUI framework. If you say, I will be making videos on these frameworks also, but for now just let us consider that Qt is a graphical user interface uh, framework which will contain many libraries that are either accessing the Windows uh, native APIs directly or indirectly. So when we are working on terminal, this is not satisfying. So we also have native API, Windows native APIs, which are the collection of dynamic link libraries and C header files, and mainly I have worked with C header files when I was doing some Windows native APIs development. Windows graphical user interface development. When I was developing some programs which actually required some graphical user interfaces, then I had to make use of the Windows native APIs. So Windows native APIs, that's a framework built by the Microsoft that sits on the top of the operating system. So working with the operating system when handling graphical user interfaces, this becomes much easier. This is the first level of abstraction, means this is the first thing, this is the first layer. Now if you make, it will provide you many handles, many APIs. This will be providing you many handles like the hardware was providing. So sometimes for inexperienced developers and the developers who belong to some other domain, some other programming language, so they find it sometimes much difficult to learn all this. Yeah, it is natural to learn all of these APIs because these are very much difficult when you are not a regular Windows graphical user interface developer using these native APIs. So it is actually a pain for you because it requires some experience, some hardcore programming experiences. So for most project developments, and for this will also take more time. So to make things further easier and also consume less time, we implement the concept of, again, the layer of abstraction, which is here Qt. So this is the Qt. Qt is again a layer of abstraction which again controls, which again manipulates all these APIs that Windows native APIs provides us. If let's say if it is providing us thousands or 10,000s of APIs, so we are just making a simple application with one button and one text box. So why should we learn all these APIs? Why should we bother learning the Windows native APIs? So we will be using some kind of GUI frameworks. In this case, we are using Qt. So Qt is a framework which has studied all of this. The developers of Qt, they are very much experienced and they have just swallowed all of these APIs. They just mixed them up and just drank them. So they know all these APIs, Windows native APIs, and they prepared some framework which is called Qt. This will be accessing all these APIs and in a more easier way, in more fashioned way, which consumes development program in less time. It will make things quicker and easier. So we make use of Qt. There are also other GUI frameworks available for most of the cases, and as per their licensing terms, their pricing packages for small projects and even big projects are also developed using Qt because it got easier learning curve and it takes less time to learn Qt, but provided that you are always experienced with the C++ and high level languages in object oriented pattern. So when I'm telling you that, when I'm asking you, do you know high level language, any high level language, you're saying yes, I know C++, Java, .NET. That's fine, but do you know how to create a program in object oriented way? Means making use of objects, classes, and all of those concepts like inheritance, abstraction, encapsulation, and all of those things. So when you say no, you can only write a program to print hello world in C++ in programs like high level languages, .NET, Python, then this will not make any sense, because as our C language is only providing us the procedural paradigm, the procedural pattern, we have no way to make objects, make classes, make objects of classes, and implement all those concepts like inheritance, encapsulation, abstraction, polymorphism. We are not we do not have any options for using these concepts in programming languages like C, Fortran, COBOL. All of these languages, these are procedural languages. So when creating for larger projects using C programs, using C programming language, and when making larger projects, it will not make any sense, because to achieve all those features, to fulfill all those requirements, software requirements, it will take longer time. The development curve will be also difficult, so overall experience will be bad. Because when we are using languages like high level languages, C++, Python, .NET, Ruby, all of these languages, they will provide us another way of programming paradigm or pattern, that is object oriented, which will be providing us concepts like encapsulation, inheritance, polymorphism, and abstraction. So this will make our programming experience even good, because when implementing these concepts, we will make things in no time. We will make things very much quicker and easier way, because they are very much powerful. These concepts are very much powerful, and that you will not understand at this moment when we will be doing object oriented programming, which is not possible in C. We will be seeing that in Java, in Python. So this is the case for Windows native APIs. So this is only required when you are doing Windows native APIs. This is not only for GUI. This is for the overall operating system. The overall operating system will provide you, as I draw a diagram. I have drawn a diagram in my earlier videos, that your hardware provides lots of APIs. Then the first level of abstraction will be the operating system, which is further divided into kernel and shell. The kernel will be providing lots of APIs. The shell will consume all of those APIs and will give you only few APIs. So as we are adding layers of abstraction, we are making things simple. And Windows native APIs are the APIs for the operating system. These APIs are provided by the operating system itself, be it the kernel. Okay, the kernel is providing us the Windows native APIs, or something between the kernel and the shell, because things are not that much easier when you start working with the documentation. You start the documentation, reading the documentation, you will find that concepts are these things, but the concept is same, but the number of abstractions, the number of layers of abstraction might be there might be some other layers also, like first the kernel, then the shell, and finally the applications on the top of the shell, but there could be some other one or more layers for abstraction between the kernel and shell. This could be, but this is not easy to tell because you will have to read their Microsoft's documentation for their operating system, for their native APIs, how the total architecture works, and that is a thing which requires different separate session. If I want to cover all those things, then I will have to make another session, because I'm supposed to talk about C programming here, but somehow I had to move on to Windows native APIs. So just for now, do not make this session too much long. Just understand one thing: we have native APIs which are provided by the operating system, by the kernel, or some layer on the top of the kernel, not the bottom of the kernel, but the top of the kernel. Any layers of any one, or there could be one or more layers of abstraction, so any of them, but definitely from the operating system side we are getting the Windows native APIs. So, and finally, as these things are too much difficult when we are handling, let's say this is not only for handling graphics, let's say these APIs are responsible for handling graphical user interfaces, but even these APIs will number in hundreds. So just to create a simple form to add one button and one text box, we will have to learn hundreds of APIs. So the number may vary, but is it legit, is it satisfying to learn hundreds of APIs, even 50 APIs, to just only make one form with one button and one text box? So we are making use of GUI frameworks like Qt, and there are a lot other frameworks also. And finally, we are writing a C program, but we are also using when writing a C program separately, we are also making use of Windows native APIs, because without using these APIs, you cannot communicate to the operating system, because operating system gives you only one way, these APIs. Without accessing these API, you cannot do anything on the operating system. So you will finally have to handle these APIs by any means, either access this directly or some by other ways, like adding layers of abstraction. Let's say finally you are adding too much layers, 1, 2, 3, for many layers of abstraction on the top of these Windows native APIs, and finally you are left with only 2 APIs. So when you are accessing these 2 APIs, you are finally accessing these APIs, let's say 20 APIs together, which will give you little control to control. When we are accessing 20 APIs using only 2 APIs, it means you are given very little control to control all of these 20 APIs. APIs are the handles. So when you have, it's like that you have 20 settings, yes, no, or low, high, or low, medium, high. You got 20 settings, and you are not that much experienced to handle all those 20 settings. So you have made some way to add levels of abstractions, and finally you are getting only 2 settings, yes and no, high, low, medium, or high, low, anything. You just got 2 APIs. So when you are accessing only 2 APIs here, behind the scenes your 20 APIs is being controlled. All of your 20 APIs are being controlled by only using 2 APIs. So what will be the thing is, you are given very less control. You are limited to only 2 APIs. So most of the things you cannot do. They are in their default stage. These APIs will be in their default stages, and like yes cannot be changed. Yes means yes, no means no. If somehow you know how to control this API directly without by bypassing the levels of abstraction, then you will be able to control all of these 20 APIs. So similar thing here, when we are just want to make one form with one button and one text box, we do not want to learn all the API, all the graphical things, options, settings. So because it is not much satisfying, it is not legit to bother. So we will just make use of some kind of framework where we will just have 2 or 3 or 4 likes things like that. The similar analogy, we will get very few APIs, and finally we will be controlling all of these APIs, graphical thing, and finally we achieve the result. So we are actually left with very when we are using the Qt or any graphical frameworks, we have also less control over the native APIs, because we cannot reach here. We are using these APIs using some kind of framework. If somehow we can bypass this framework, this level of abstraction, this is a level of abstraction, or abstraction means something that is like a wall that is restricting us to reach here. So somehow we can bypass this wall, this level of abstraction, then we will be able to access all of these APIs and we will have even more control. But in case of GUI frameworks like Qt, why I am talking about Qt? Because Qt is very much a rich framework. It will give you all of those important APIs that you should that you will require in making any graphical content, any graphical application. So then we do not bother using the native API directly. We are satisfied with the Qt. But who are experienced Windows native API developers or app developers, they will for most cases they will not use any framework, because they are very much experienced with these APIs. They will use them directly, and as we are bypassing this abstraction, so our application will be also less in size, but it will take more time to develop, unless unless you are inexperienced. If you do not have experience, then working with native APIs will take you more time. If you are experienced, then this will be the fastest thing in case of execution and in case of development also, because you know all of the things. But the writing time should be more, because you will have to write all of those APIs. You will have to write more code, so the development time will be little higher, but the application will be faster and the size will be also lesser. Because when you have layers of abstraction, the abstraction is itself a piece of abstraction, means the framework here. So framework, if you are not using all of those modules, even 4 to 3, 4 or 5 modules, their size will be added to your final program. But when you are not using any of the framework, you are directly accessing the things what every operating system already has. So your application size will be, when using this directly, your application size will be less, it will be faster, but the development time it may be higher. So for today, let us finish the session here, and thanks for being with me. If you have any doubt, please let me know. Thank you for watching.